The fate of the sun is the same as for all stars. One day, they must all eventually die, and the cosmos will be plunged into eternal night. All stars eventually will run out of fuel. Temperature of the universe drops. Stars, one by one in the night sky, will turn off. And there will be no more new stars created. And so the universe will end not with a bang, but with a whimper. And not in fire, but in ice. With the death of the last sun, the age of starlight comes to an end. The universe becomes a cosmic barnyard, strewn with remnants of dead stars. Our sun becomes a white dwarf, a hot, dense, shrunken stellar corpse. With no fuel left to burn, a white dwarf's faint glow comes from the last residual heat from its extinguished furnace. Looking at it from where the Earth is now, it would only generate the same amount of light as the full moon on a clear night. The faint glow of white dwarfs will provide the only illumination in a dark and empty void littered with dead stars and black holes. In some ways, it's kind of a ghost universe. It's the corpses, the zombie stars, that will take us into the future. Over time, gravity ejects dead stars and planets from their galaxies, sending them out into the freezing void. By chance, some brown dwarfs collide and form accidental new stars. Colliding neutron stars puncture the darkness with ultra-bright supernovae. Any surviving life forms may find refuge around aging white dwarfs. But in time, even the white dwarfs will fade and die. A black dwarf will be the final fate of those last stars. White dwarfs that have become so cold that they barely emit any more heat or light. Black dwarfs are dark, dense, decaying balls of degenerate matter, little more than the ashes of stars. Their constituent atoms are so severely crushed that black dwarfs are 1,000,000 times denser than our sun. Stars take so long to reach this point we believe there are currently no black dwarfs in the universe. Any matter that fails to escape its galaxy is sucked into a supermassive black hole at the center. Long dormant black holes flare up in a blaze of glory. The rotational energy of black holes becomes the last reliable source of power for any exotic future civilizations. We have a pace of life that's based on the energy available to us now. You could imagine living, conscious systems, which have a very different pace and therefore can extend out at least a lot farther than you'd imagine otherwise. You could have a living system where if it had a thought every 10 trillion years, that would seem normal. Ever if our life dies out, one could imagine at some time arbitrarily far in the future, a fluctuation occurs which allows intelligent life to exist again for a little while. So you might have islands in time of intelligence. As the expansion of the universe accelerates, it begins to spread matter apart faster than the speed of light. By this point, distant galaxies and stars are receding due fast that their light has become undetectable. The secrets of the cosmos are locked away forever. Current theories predict that atoms themselves will begin to decay, destroying all remaining matter in the universe. A proton, one of the fundamental building blocks of atomic matter, what makes us up, can just spontaneously fall apart. Any material that evades the pull of a black hole eventually dies away as its protons disintegrate. Proton decay is still unproven, and so this chapter of the future could look very different in light of new discoveries. The matter inside black dwarfs, the last matter in the universe, will eventually evaporate away and be carried off into the void as radiation, leaving absolutely nothing behind. With the black dwarfs gone, there won't be a single atom of matter left. All that will remain of our once rich cosmos will be particles of light and black holes. The black hole era begins. No planets, no stars, no lingering stellar remnants for life to cling to. Yet even now, space-time like mallets on a drum. And have a very characteristic song. Imagine two black holes that have lived a long life together. At the end of their lives, they're going around each other, crossing thousands of kilometers in a fraction of a second. As they do so, they leave behind in their wake a ringing of space, an actual wave on space-time. Space squeezes and stretches as it emanates out from these black holes banging on the universe. Those are the gravitational waves and are literally the sounds of space ringing. And they will travel out from these black holes at the speed of light as they ring down and coalesce into one spinning, quiet black hole. If you were standing near enough, your ear would resonate with the squeezing and stretching of space. You would literally hear the sound. Imagine a lighter black hole falling into a very heavy black hole. The sound you're hearing is a light black hole banging on space each time it gets close. As it falls in, it gets faster and it gets louder. Scientists used to think black holes were immortal, but even these will one day die. Now we're talking about timescales of unimaginable length, quadrillions of years into the future. On that timescale, even the black holes begin to evaporate. According to quantum mechanics, space is filled with virtual particles and antiparticles that are constantly materializing in pairs, separating, coming together again, and annihilating each other. In the presence of a black hole, one member of a pair of virtual particles may fall into the hole, leaving the other member without a partner with which to annihilate. The forsaken particle appears to be radiation emitted by the black hole. And so, black holes are not eternal. They evaporate away at an increasing rate until they vanish in a gigantic explosion. Quantum mechanics has allowed particles and to escape from the ultimate prison, a black hole. Black holes begin to evaporate away, erasing the last large-scale structures in the universe. As they die, they light up the darkness one by one. As the black holes slowly die off, the universe continues to expand, driven by a mysterious force we don't yet understand. This is the frontier of human knowledge, a frontier ripe for exploration and discovery. Philosophers and poets have asked the question, will the world end in fire or ice? We can now give an answer. The latest evidence shows that the universe is not slowing down, but it's speeding up out of control. And the universe, we think, will die in ice trillions upon trillions of years from now. Empty space itself has energy. In every little cubic centimeter of space, whether or not there's stuff, whether or not there's particles, matter, radiation, whatever, there is still energy, even in the space itself. And this energy, according to Einstein, exerts a push on the universe. What is the weird stuff that's accelerating the universe? We call it dark energy. And this stuff is the dominant stuff of the universe, almost 3/4 of the matter-energy content of the universe. Is this dark energy, and we don't know what it is. Dark energy, unlike matter or radiation, does not dilute away as the universe expands. This has crucial implications for what the universe is going to do in the future. So what will be the future of the universe? Well, if the dark energy remains dominant and repulsive, the universe will expand forever. Faster and faster and faster with time. A runaway universe. "70% of the energy of the universe resides in empty space, and we don't understand why. But we do know what will happen. If that energy continues to be there, the universe will become cold and dark and empty. That's the future as it might be. We don't know because we don't yet understand the nature of dark energy. Until we do, we won't know the future. We won't even understand our own origins. And that's why we want to know and study this subject. Discovering the true nature of dark energy could change our vision of the future dramatically. If it somehow weakens over time, the universe could collapse under gravity, a big crunch. Given a boost, it could tear the universe apart at the seams, a big rip. Physicists increasingly suspect that there may be multiple universes beyond our own, each with their own unique laws of physics. Some would harbor the right conditions for life.